Now here we see the logistic regression model, and then here we see the gradient boosting confusion matrix. So the actual predictions made by the model that matches is 65 and 79. But then when you look at the numbers where the predictions was wrong, that comes down to 25 and 31, which adds up to around 56 of the entire data provided. For the XGB model, this number will give us just 22 of the 200 records that is going off of the right predictions. Now to compare the traditional logistic regression model with the XGBoost classifier, we will first import NumPy, Pandas and Matplotlib, SNP, Pandas, SPD, and then Matplotlib for visualization, .pyplot, SPLC. Then we will import from scikit-learn the logistic regression model. So from sklearn.linear model, we will import logistic regression. This is the standard model which is used for classification tasks, so logistic regression. And then we want to also have the XGBoost classifier. We are going to compare those two and how it performs. So from XGBoost, we want to import XGBClassifier like that. And then in order for us to obtain a dataset, I'm not going to import it from anywhere, rather I'm just going to create it inside. And I will use a function called makeClassification. This will help us create a dataset. Datasets import makeClassification. This will help us create a random dataset which can be used for testing various different models. This makeClassification function can be used to create a classification dataset. Let's show you how. Over here, let's just straight away type in X label and Y label and then use the makeClassification function. Classification, inside this we want, let's say, n samples, so let's say 1000. This will indicate the number of records that we need, and then n features, which indicates the columns or the number of parameters that we need. I will have this to be 20 like that, and then out of which how many of them have to be informative, that is, which can actually be used by the model to make reliable predictions. I'm just going to set this to be 10. So out of the 20 columns, 10 of them are going to be really informative. And I'm also going to set the n classes to be 2. We just need 2 classes, 0 and 1, because we're going to be performing classification. So let's just set that to 2. And then I will split this into 80% and 20% as train set and test set. This is to evaluate how the model is performing. In order for us to do that, we will have to import the train test split function from scikit-learn. So from scikit-learn.model selection, we want to import train test split like that. So now when we come over here, actually let's just run this. After we have done that, let's type in xtrain. So we have a train set and xtest, follow it up with ytrain and ytest, which will be use the train test split function that we imported, pass in the x data and the y data, and then mention the test size to be 0.2. This indicates that we want the test set to be 20%. The test set is the one that we're going to use for evaluation. Let's just do that. And now, before we move on to creating the model, I actually want to show you what the data set is. When you print x, you most probably are not going to understand about it much because it has some random numbers that was generated by the makeClassification function. But then when you look at the y label, it will only have 2 values, 2 classes, one is 0 and the other one is 1, because we mentioned n classes to be 2. When we mention this to be 3, we're going to get an array which contains 0, 1 and then 2 like this. For this case, we just need 2. So let's just have this to be 2 itself. Run this once again, then run this. And then we perform the train test split for the 20% split to the x test and the y test, and 80% of the original data is just going to remain in the train set, which will be provided to the model for training. Now with that said, let's just get to creating the model itself. Get over here. First, I'm just going to create the logistic model. This is a traditional model which can be used to perform basic classification, logistic regression. We imported this above. We can use the logistic model.fit function and then pass in the train data and the test set there. Xtrain, ytrain, like that. Again, we provide this data to the model for it to train and understand the patterns. I'm just going to do this for XGB model as well. Paste it over here, then change this to be XGB model, like that. Call this to be XGBClassifier that we imported above, like that, and then pass in the xtrain and the ytrain like that. Now, before we run this code cell, let's just also make the prediction variable as well. Linear predictions will be linear model.predict. This predict function will give us predictions for a given set of values, which will be our test set that we split off from the main data set, xtest. Then I'm just going to copy this for the XGB model as well, XGB, like that. And now let's run this code cell. It's not going to return any value. You have to type this as logistic model. Now run this on this. So it's not going to return us any value because we're actually going to directly use the linear predictions and the XGB predictions in plotting to see how the model performs. But first, let's just show you how the accuracy is for both the models. For this, let's import the accuracy score from scikit-learn.metrics. Type in from sklearn.metrics. We want to import accuracy score. And I'm also going to import confusion matrix as well. This will help us understand how both the models are performing, and we can come to conclusions of what is doing better than what. So confusion matrix, and I'm also going to import confusion matrix.display like that. This will help us plot the confusion matrix that we're going to create. But first, let's just have a look at the accuracy score. Linear model accuracy. Actually, let's just call this logistic accuracy, which will be accuracy score function. So this, you first mention the original value, that is the white test, and then the predicted value, that is logistic predictions, like that. Then we can also do that for XGB model as well. Copy this, paste it, XGB, just to be logistic predictions like that. And then let's print those two to see how it is. Logistic accuracy, and this is XGB accuracy. And then let's just print this. So run this code cell to see the accuracy. We see that for the given dataset, the accuracy score for logistic regression is just 72%. But then when you look at the XGBoost accuracy, it is around 90%, the 89% mark. Now let's just plot a confusion matrix to see how it's actually performing in terms of the actual value and then the predicted value. So to do this, first let me just create two variables, logistic CM, follow that by XGBCM. So in order to do this, let me just create two new variable, logistic CM, follow that up with XGBCM. Both stand for confusion matrix, and use the function that we imported, confusion matrix, to obtain the initial confusion matrix. Just like you did for the accuracy score, you pass in the white test, that is the original values, and then the logistic predictions. Like that. Do this similar. Actually, you also want to mention the labels. I'm just going to copy this for XGBoost model as well. Copy this, paste it over here, change this to be XGB prediction, like that. Now that this is done, let's just run this. Again, this is not going to show us anything because we're actually going to plot it. So I will be using matplotlib once again. plt.figure, fig size will be 12,6, like that. And then create a display variable. Use the confusion matrix that we just imported, the confusion matrix display. Pass in the logistic CM, stands for logistic confusion matrix. And then here, display labels will be standard 0 and 1. I'm just going to copy this. Let's just type in display.plot and type in plt.show. Like that, and then paste the one that we copied, change this to be XGB confusion matrix, like that. Again, display.plot and then plt.show. Now this will give us two confusion matrix, and this will be easier for us to compare and come to a conclusion. So run this. Let's just set the title so that we can better understand this. plt.title, first one will be logistic, the other one will be XGB, like that. Now let's just run this. Now here we see the logistic regression model's confusion matrix, and then here we see the gradient boosting confusion matrix. So here the actual predictions made by the model that matches with actual 0 is 65, and then when the actual label is equal to 1, and the prediction label also has the value of 1, in that case is 79. But then when you look at the numbers where the predictions was wrong, that comes down to 25 and 31, which adds up to around 56 of the entire data provided, which is not very reliable. Now, when you look at that for the XGB model, this number, when adding up, will give us just 22 of the 200 records that is going off of the right predictions, which is more promising and more reliable. And this is why XGBoost is preferred over the traditional logistic regression model. It uses their decision tree system once again to identify the patterns and the outliers, etc., and comes to a better conclusion and makes better predictions.